We did an example before like this. Does the root have any problems? It's an odd root. He's all cool with everything. But the inside is not a problem. Where? True. Where, what value of x makes the inside freak? -4. So then, no problems here. He's only got one problem, so there's only one thing you throw out. You throw out -4. That's the way to look at domain. Who's got the problems? They all accumulate. He's got no problems. Oh shit, I got to throw that one number out because the inside can't have 0 on the bottom. Maybe. Okay. All right. I think we did every problem on it. I was like, which one did we not do? I think we did. All right, so let's review what we did last time so that we can get into some new stuff here. We got to do that one last problem on the sheet, but I want to do a couple of reminder problems and then we'll do that last problem. We did something called completing the square. Right, this does not mean I'll give you a picture and you go, I did it. No. This is the idea of I have parts of x and I want to give it something so it becomes something squared. Because remember, recall, if I have this, let me throw some other stuff in there so I can review. This is relatively easy. The thing you got to fight against is sort of programmed in you is to not foil this bad boy. Because then you got all these parts of x you got to worry about. It's much better just to right now kill that thing. How do I kill that square? Square root. And when I do that, of course, what if I give myself two options? Is it going to work? Yeah, that's what I said. Square root.
Plus or minus?
Thank you. So this side just becomes that. What's the square root of -9? 3i. If anybody wasn't here yesterday. Sorry. And the day before that, too. You might want to email me so I can send that link to the video we watched. I think the video is good. And then the last thing here is add 7. Like always, get the x by itself. How many answers are there? 2. I like it, which makes sense. So squared. I like it. Little teaser, based on what I just said. Little teaser for later today. How many answers should there be to this question then? 3. I can only see one answer though right now. Well, I can see 3. If I'm in this class, sorry, showing off. We can only see one answer to this, right? What's the one answer I can see? Yeah, what do you cube to get 8? 2. There are 2 more things that you cube to get 8. They are complex. Kind of makes sense. I can see the real answer right away. The complex shit I can't see, and we're not even sure how the hell to get them. But I know there's got to be 3 answers. I can't escape that. There's got to be 3 answers. It's just that the other 2 answers are complex. We wouldn't even know how to begin to approach them until recently. So we'll do that later today. We'll figure out the other 2 answers to that. So you guys are like, I'm okay if we don't. We will. Okay, so what about, so this problem is relatively easy because I got all my x stuff collected inside of a square that I can just kill. And then I end up with this beautiful, just one step away from getting x by itself. Right? So, that kind of led us down a road of, how do I get something in that form that isn't currently in that form? What are you doing, Jeff? I don't know, man. Let's do, yeah, I like it. So who remembers the steps for this completing the square? First step is cut 10 in half. And then take that answer and do what? We would just undo what we did if we did that. Square that bad boy. What's the 25 used for? Yeah, that's what goes here. If I add 25 here, I better add 25 there. Sweet. Right. And the whole reason we did that shit, and again, I'm not going to go through it again, but we saw a few, we developed a pattern. Because now what have I done? Well, how do you factor this guy? We made it so that it's going to factor like this, in this form anyway, right? But it's going to be what? X plus 5. So we gave it the one thing it was missing so it could get put together in that little compact form, and then I can attack the square directly. Instead of trying to, if I subtracted 2 over, I couldn't factor it. I couldn't even do that. It's the only other thing we know how to do. So continuing, I would do what? Square root. Plus or minus. Do this side. That side you could do something with. You got to start looking for that. Yeah. So it'd be 9 times 3. Square root of 9 is 3. Square root of 3, I don't know. Is that cool? Break it up into rad 9, rad 3. Rad 9 is 3. Rad 3, I don't know. No? Yes? No? Yes. And then one last step. Force it out in front, just to put it in this kind of form here. And if you wanted to, you could plug this back in and check it. If somebody forced you to do that, you could, but that's not. Okay, so let's do one that's not quite as nice and show you that it's really not that bad still. This step just kicks so much ass because that's how this is going to factor. So if I get really funky ass numbers up here, these steps are easy. Cutting something in half, easy. Squaring something, easy. And this tells me how this is going to factor. So it almost doesn't matter what weird shit is there. I don't have to think about factoring. It's already factored for me at this step. So, if I add something like this, what do you got, John? Yeah, let's get really freaky. Why not? Yeah, I like it. So you can tell already that this is not going to be the best because I can't cut the middle in half nicely. Right? But I can still do the steps. First step is, see, I've already got room. This is a 1. Everything's in the right format. The next one we'll do is, what if that's not a 1? So that means the process will work. So what's the first step?
11.
Yeah, careful now. Negative 11. There, leave it like that. Second step? Squared. What's negative 11 over 2 squared? No negative, right? Negative times negative, positive. 121. 11 times 11 over 4. All right, let me stop for a second. You start to see, I mean, I've been saying this whole semester. There's a process that don't give a shit what's in there. The process just says, do this, do this, do this. Then we go, oh, it's a fraction. The process is like, do the same thing. And we're like, shit, that means I got to top and think. I got to top it up. I'm going to have LCD to get in a minute. Because what's the next thing I do? What do I do with this? Put it in there. That's what I left some room for, right? And if I put it there, I better put it there. And I'm going to need LCD to get those together, right? How do I factor that first side? This is that was a 5, right? 5. That first step tells you. So how do I factor this? X minus 11 over 2. That's what I mean. You don't have to sit there and think, what two numbers multiplied by 121 over 4? What the shit, Mr. Waller? Yeah, it's right there. It's part of the construction of the problem that what you get on the first step is how it will factor. What you get on the second step is exactly what you got to add to make that work. It's too too nice to believe. How do I do this side? I'm going to have to get, not too bad, right? So 28 plus 121, 149 over 4. What's up? Everybody all right? And then I square root, plus or minus. I'll do this side. It's the only thing you can do on that side. Can you do the square root of 149? No. Can you do the square root of 4? See? Let me put that plus or minus 4 like. There we go. And then the last step is the same as before. You just add whatever the hell's with x. Those of you that know quadratic formula, doesn't that look like a quadratic formula answer? Because it is. Quadratic formula is just a shortcut to this. That sometimes takes longer than this. Figure that one out. Alright, so let's do that one that's on the sheet. So who doesn't have that sheet? There's a... Oh, here. On one side it says complete a square. On the other side it's got a whole bunch of writing with some red words. Everybody got that? Okay. So let's do this bad boy. Yeah. Yes. All right. What's the first thing I've got to do on that second problem down there?
The x squared by itself?
No, not quite. I think I know what you mean, but get rid of the what?
9.
Get rid of the 9. Yeah. Not really get x squared by itself, but gotta make some room. Get rid of the 9 by dividing it. Oh, this problem looks really yummy. So you get x squared plus 3x equals 5/9. Try to do the next 2 steps. Try to complete the square. So what's the first step here? Bam. And then square it. So what do I do with that 9 force? Good. Factoring here is no problem because we don't have to actually do it. We just throw that number in. It's built so that's how it works. It only works if there's a 1 here, which is why I had to kill that 9 first. You don't get a choice. You make fractions, too bad. And then over there, just gotta get those together. How we doing? Everybody all right? So this will be, needs a 4, needs a 9, so it'll be 20 plus 81, right? 20 plus 81 over 36. Become a 36. Is that right? You needed a 4. You needed a 9. And now I've got the completed square part is done. And its whole purpose was to make this so I could attack the squared thing directly. So now I, of course, take a square root, put my plus or minus. So over there, you should know what to do now.
Square root those numbers. So
Yeah.
on the bottom, like 6 on the bottom.
Yeah. I ain't gonna do nothing. Or a little 101. And then last step, subtract 3 halves. So it really just kind of goes right there in front. So even if fractions show up, it's only minimally harder, right? The process barely changes. It's just a couple places you got to worry about LCD or something like that. Process barely changes. So, now, oh shit. Somebody back in history decided to try to shortcut this method. It kind of makes sense because it keeps doing the same thing. Yes?
We couldn't square the 101, but we did the bottom. Right?
Yeah, the square root of 36 I know is 6, but 101, yeah, I can't even break it up nice. Yeah. So I'm going to do with you, you're going to help me, the whole completing the square process to solve this. I really want you to understand why we're insane like this. What math people like to do is, if I'm doing the same stupid thing, I don't care what numbers I put here, I do the same damn thing. What if I would have put a 7? I would have divided by 7 and done all the same shit. We go, there must be a shortcut. There must be a way to get the bulk of the work done and then plug values in the right place. So this is where the quadratic formula comes from. Now don't freak out that there's an A, B, and a C. Again, if I would have put a 7, our first step would have been divide by 7. If this would have been negative 22, I would have divided by negative 22. So what do I divide by? A. Shit, yeah. And let me also, it's always a step about making room, right? So I get A gathered. I get x squared plus b over ax. I'm going to subtract c over a to make some room here. Is that cool? You stop there for a second. Kind of like those of you that aren't writing this down, because it's all in the book. You don't have to necessarily write this down. You can help me out. So now what do I do? Again, what's there doesn't tell me what to do. It's the form it's in that tells me what to do. What's the first step and the second step?
Divide by 2.
Yeah. Say it a different way. Cut b over a in half. So take half of b over a. That's what b over a divided by 2 is. It's b over a times 1/2. So you get b over 2a. I don't know if that's ringing any bells for anybody. And then I do what to that? Squared. What's b over 2a squared? B squared over 4a squared. I got twice what? Twice always. Everything gets doubled. Everything gets squared. Okay. So where do I put this? I always imagine somebody's like, I'll tell you where to put it, John. Where do I put that? Here. And? Let me stop for a second. See, the process isn't changing at all. And in a way, some people kind of notice this. This is actually better because I can't put B and A and C together. I actually have less work to do. I know most of you, I don't believe that. All right. How do I factor this side?
Isn't it that?
Yeah, it's going to be what? X plus B over 2A squared. See, I mean, that's part of the process. That is ugly. I don't care. You just throw it in there. That's almost too nice to believe. That's how the process was built. And over here, what do I need? Same idea we had over there. What do I need? Good. This guy needs a 4A. That really should hopefully start looking familiar to some of us. So what do I get? I get B squared minus 4AC. Oh, all over 4A squared. It's not quite there yet, Jay. We're not quite done. Again, this is a derivation. This is nothing you're going to have to do yourself. But I want every step to make sense. It's the same process. And now, of course, what do I do? Square root, plus or minus. So over here I get x plus b over 2a. What's the square root of the bottom? 2a. And up here I just get this. Yeah, then I just subtract that over. And they have LCD, don't they? See that? So I can put them together. So if I subtract this over, it's going to be negative b plus or minus square root of a squared minus 4s all over 2. So what's the quadratic formula do? It finds out where this equals 0. Why is it called quadratic? Because this is called quadratic in form. Quad means what, though? 4. So why the shit is that called quadratic when it's only got 2? Because it comes from the area of a square. That's why they call it quadratic back in the day. It came from kind of like a 4-sided figure. You saw that earlier in the homework. There's some questions. Yeah.
Wait, I don't know how you did the last step. We probably need to subtract B.
Yeah, subtract b over 2a over. So if I subtract b over 2a, they have LCD already. So I can put negative b plus or minus this on the top because they have the same denominator.
Do I have to write it twice? You don't have to.
Right, what twice?
The 2A. Since
What's 2 7s plus 3 7s?
5 7.
Okay. Right? You don't write 14ths or 49ths or something crazy. It's just 7s. So this many 2 over 2a's minus this many over 2a's is this many over 2a's. Yeah. You're just consolidating stuff. That's why the bottom doesn't change. It's the thing I'm keeping track of. All right, so let's use this thing to do this problem. Let me remember this answer here. The answer is supposed to be this. Become a negative 3s. So we already know what the answer is. Let's try to use that formula we just got to do this. So what's kind of wrong with the way it starts off? What's in the wrong place? For that, what's it got to look like? ax squared plus bx plus c equals 0. So of course, yeah, let me bring that guy back over. Is that cool? So what's A? What's A? 9. What's B? 27. Oh, that's got to be gross. What's C? -5. So x equals negative b, and now it's just a plug and shove. Plus or minus square root of b squared, oh yeah, minus 4 times a times c. Maybe, yes. So we did the problem. How many problems did we do right here? How many problems did we do? Infinite number. We did an infinite number of problems right here. We did every single problem that's possible that looks like this. We're done. We just have to put in what the values are for the specific situation. So whatever A is, whatever B is, whatever C is, if I just put them in, I'm done. Well, now I got to clean things up. That's the other part of this. Over 2A. And now let's see what I can do. X equals negative 27 plus or minus 27 squared. I don't know. Shit. What is it? Let's see. 3 to the 6th power. Oh, it's 7. Is it 729? No. Is it 729?
729.
What is it?
729.
729. Okay. Minus a negative. Is that cool? You guys see that? So it's going to be plus 20 times 9 is 180. Always look for your round numbers, right? 4 times 5 makes a round number. That's nice. Yes. Over 18. Is that the same as that? Yeah, it is. X equals negative 27 plus or minus square root of 8. What is this going to be? 909? Do you guys see something neat about 909? It seems to be the word of the day. It's 9. Yeah, what can come out? 9 can come out of 909, and 9 is a square rootable number, right? Do you guys see that? So I'm going to simplify this. So this is going to be negative 27 plus or minus. Square root of 9 is 3. If I take a 9 out, what's left? 101. All over 18, and then I reduce shit, right? So what goes in? So I can divide everything by 3. Well, if I break it all the way up, it'll be negative 27 over 18. Give or take, 3 over 18 is 1 over 6, right? And 27 over 18 reduces to 3 halves, divided by 9, right? Same answer, same answer. 2 different ways to get to the same answer.
What chapter is it?
Oh, 11.2. It's the section's titled Quadratic Formula. Oh shit. Has anybody, it's okay if this is true, but has anybody like never seen this before? Yeah? You guys? Okay. Alright, so I'm sorry if I say that, because I'm so used to this having been seen at some point, but if this is brand new to anybody, I'm hoping you can see how it's just, it's called a shortcut because we actually did the whole process once, and then I can just throw in what A, B, and C are at the end instead of at the beginning. So that's the idea. So anything in the form ax squared plus bx plus c equals 0, I can do it. And I don't have to divide by A or any shit. I mean, it's got a few kind of nicer things to it, right? Maybe? So on the other side of this sheet, on this side, there's everything we've done so far in terms of how to solve ax squared plus bx plus c equals 0. There's the 4 main ways to do it. Can your answer come out complex? Can anybody tell me what would tell you you're going to get a complex answer? What part of this? Where? Yeah, so if b squared minus 4ac, if that number is negative, you are going to get 2 complex answers. I like it. Oh, I promised you this. And you guys are probably like, it's all right, man. You don't have to keep up with your promise. But real quick. Oh, you guys are going to hate me, but I'm used to it. It's all right. So if I wanted to solve this, there's supposed to be 3 answers, right? Yeah. Just go with me for a second, and then I'll let you out. Subtract the 8 over. What can I do on this side now? Little dude, big dude. 1x minus 1, 2. Is that cool? The other 2 x's, the other 2 2's. 2 times x in the middle, cleanup guy. Here's where I get x equals 2, right? Because if I set it equal to 0, x is 2. How do I solve this equal to 0? You do that shit, right? And that's going to come out complex. How can I see that? What's A? 1. What's B? 2. What's C? 4. What's B squared minus 4AC? Why is that the most important part in a way? Because that's the part that's in the radical. It's going to determine if it's going to be real or complex. So what is 4? Yeah, 2 squared is 4. Minus 4 times 4. 4 minus 16 is negative 12. It's going to have 2 complex answers. That's why we couldn't see them before. I could only see the 2. The other answers are going to be freaky. Exceptionally freaky. And I wish I could tell you the whole story, but it gets really freaky after that. But that's enough, I think, for us for now. All right, everybody got a practice test, right? So tomorrow's going to be review day. We made it, I'll make it official that we made it up through 11.2. I'm not going to get, there's a problem from 11.3 on the practice test. The very last problem, number 8. It's kind of related to what I just did, but it was so quick I'm not going to make that official. So we officially made it up through 11.2. All right.
Where is it starting at? 10?